All right, so here is section 5.3, part 2. Calculate the moles of reactants and products present after the reaction of 0.250 PCl5 and 1.5 moles of H2O is complete. Okay, so again, what we're doing is a ratio of the moles of our reactants to our products. And so what we need to do is we need to say 0.250 PCl5 and then develop our balanced chemical reaction, which tells us 1 mole PCl5 gives us 1 mole H3PO4, and that gives us basically a ratio, or it tells us that we're able to produce 0.250 moles of H3PO4. Meanwhile, when we do the exact same thing, 1.5 moles of H2O, we see 4 moles H2O for 1 mole H3PO4. Gives us 0.375 moles H3PO4. And remember, our aim is to figure out which one of them gives us the lower amount of that product. Now we could have done the exact same thing with HCl, it doesn't really matter. Our aim is to figure out which one of these numbers of moles, or which reactant, and based on the number of moles that we have of it, gives us the total number of moles that are produced, or the lower amount of the two. Okay, so now the question is, calculate the moles of reactants and products after the reaction. Okay, so we'll set up PCl5, H2O, H3PO4, and HCl. Okay, so PCl5, we know that none of that is going to be left. That is completely consumed. Okay, after the reaction has come to completion, we also know that 0.250 moles of H3PO4 have been produced. Okay, did we have any H3PO4 to start out with? No, we didn't. Okay, the next thing that we want to do is set up, well, we can scribble this out because we don't care about that, 0.250 moles of PCl5, 1 mole PCl5 will produce 5 moles HCl. So 0.250 times 5 gives me 1.25, divide that by 1, and lo and behold, I'm able to produce 1.25 moles of HCl. Okay, great. Now the last one, 0.250 moles PCl5. Now remember, now what we need to do is we need to relate one reactant to the other reactant. We know that if we have 1 mole of PCl5, we will need to use 4 moles of H2O. Do we have 4 moles of H2O? We don't. But do we really care about that? No, we don't. Because what we're trying to figure out is how much H2O is used. So I'll do 0.250 times 4 divided by 1, and that is 1 mole of H2O. So we started out with 1.5 moles of H2O. We used 1 mole of H2O, so we are left with 0.5 moles of H2O. Right. So this is everything that we need. All right here. And this was our first step. Okay. Now, it gets a little bit trickier though whenever you're presented with a mass. But heck, it's just adding another step. It's not a more difficult step, it's a step that you know how to do. And it all relies upon your molar mass, that information that comes from the periodic table. So as an example, What mass of sodium sulfate Na2SO4 will be formed by the addition of 14.4 grams of NaHCO3 in aqueous solution to an aqueous solution of 4.9 grams of H2SO4? Okay, so our first step is 14.4 grams of NaHCO3. Okay, my molar mass for that is, just a second, 84.01 grams. Okay, got it. 84.01 grams is the mass of NaHCO3. That's 1 mole of NaHCO3. Now what I want to do is I want to jump immediately to one of my products. 2 moles of NaHCO3 will make, let's go with 1 mole of Na2SO4. So I'm doing this the exact same way, but I'm not solving for the number of moles of NaHCO3. Instead, I'm just working that calculation into my question, or into my calculations right here. Okay, so I'll solve that. I'll say 14.4 times 1 times 1 is 14.4 divided by 84.01 times 2. That gives me 0.085. I'll call that 0.086 moles of Na2SO4. So now what I want to do is I want to figure out if my 4.9 grams of H2SO4 will produce a larger number of moles of Na2SO4. So I'll set up 4.90 grams of H2SO4. Then I will say 98.078 grams H2SO4 will produce 1 mole of H2SO4. Then I can use my balanced chemical reaction, which shows me 1 mole of H2SO4 will produce 1 mole of Na2SO4. So 4.9 times 1 times 1 divided by 98.078 equals 0.0499. Or I could go ahead and I could call that 0.05. So which one's my limiting reactant? Well, it's going to be my H2SO4, because that produces a smaller number of moles of Na2SO4. Okay, so the question though is what mass of Na2SO4 will be formed by the addition of 14.4 blah 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 blah. So now what I need to do is repeat this, which I'm going to write it all out. 4.90 grams of H2SO4. The exact same calculation, 1 mole, but I'm going to add one more step to it, 98.078. In that one more step, and I'm just writing much more brief descriptions of my substances, that one more step is 1 mole of Na2SO4. I'm going to convert this into the mass. The molar mass of Na2SO4 is 142.04 grams. Okay, so these two calculations were effectively the same. I just added this one right here. So 4.9 times 142.04 divided by 98.078 equals 7.10 grams of Na2SO4. All right, so whenever you're presented with a mass, you just need to go from the mass to the molar mass to the number of moles. When you're presented with number of moles, well, you can relate those number of moles to, or of a reactant and a product to one another, figure out which one gives you fewer, and move forward. And so This is just a bunch of simple parts that you know how to do. You just have to piece them together. It's a puzzle, and just making sure that you get that puzzle properly assembled. But I know you can do it because you're good up until this point, so let's keep it going. Deal? All right, everybody. Have a good one.